Hey, welcome back. So today is day 3 of the Tinkercad camp. We're going to be working with circuits again today, but today the code that we type is going to be text-based coding. I'm here with my trusty camper as always, McKinley. You ready to go today, McKinley?
Yep.
Are you excited to do text-based programming?
Maybe.
How are your typing skills?
Working on it.
Working on it, that's fair. All right, so we are going to be typing today, so you probably will have to pause the video some, because I type super fast, right? And I'll try to delay some here and there, but don't be surprised at all if there's times where you kind of need to pause things. So here's the circuit that we're making today. So it's using something called an RGB LED, and we'll talk more about that, but it stands for red, green, blue. It's kind of like a single pixel on your phone or TV or something like that. So we're going to be coding that up. And we're going to be learning about some of the main things in coding. So we're going to be learning about functions. We're going to be learning about variables. We're going to be learning about if statements. And I'm going to also kind of sneak in for loops at the end. So really, it's not that the things we're building are that amazing. It's that the skills that we're learning with if statements and things like that. So this light can either flash or be steady on. That's what we're going to be doing. So right now it's steady on. Now it's flashing. And then you can change the color with these potentiometers. So if I made it red and green, it would turn bright yellow. If I take down the yellow amount, it turns just red. If I turn up the blue, it kind of turns purpley, right? So that's kind of the goal. So to start things off, go ahead and open a new Tinkercad circuit. So log into Tinkercad, hopefully you've got that down, and click on Create New Circuit, and we'll get started. All right, so my project's up. It picks a crazy name to start with, and we need to come up with a name for today's project. There's no good name, so I think I'm just going to give mine a very generic name. I'm going to call it CWC, which stands for Connecting with Code 2020, current year, day 3. Not really a great name, but I didn't really come up with a good name, so that's what it is. I guess I could have called it learning about functions and learning about variables and blah, 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 blah. So the first thing we want to do is we want to add a breadboard. You can drag to bring the breadboard over, but I actually prefer to single click on the breadboard, and then it just kind of follows my mouse around until I click a second time to place it. You'll find that with Tinkercad, they usually do that, where you click once, and then you move and you click again. They actually do that a lot more than dragging. So the first thing I want to do is I want to rotate my board, so it's kind of sitting here. Next thing I want to do is I want to grab an Uno. So I single clicked on Uno, now I'm not touching anything, and I'm actually going to rotate it before I place it this time even, right? So I rotate and then I click a second time to place it. So this configuration is what you use a lot when you're kind of learning this type of material. And there's a lot of boards that are set up like this. I didn't bother bring my physical board today because we're going to do everything on the simulation today. So the first thing that you do want to do if you have a setup like this is you want to connect the power and ground from your Arduino over to the breadboard. And what I'm going to do is I'm going to put power and ground in kind of high up on the board. So I'm going to connect my power to row 6, the red line that's right next to row 6. And you can click on the 5V over here, and then you can click on the plus rail. Really, you can put it anywhere in the plus rail. I put it in row 6 because I know that's where the spacing is going to work out. If you don't care about pretty, you can just stick it right on there and be done. If you do care about pretty, what you can do is you can double click and add some bins to your wire. And if you want to, you can double click and you can add these pretty bins to kind of make it look a certain way. Another thing you can do if you want is you can change the color of wires. You can click on them and you can select it here. Or there's some shortcut keys that you can memorize. So 2 would have just turned that red. The other thing I'm going to do is I'm going to connect ground. So I'm going to kind of put it right below it. And if you want to, you can make these fancy bins while you place the wire. And then here I'll just press the number 1 to put it in place. Trying to do it when I make the wire is okay, but I actually kind of prefer to do it after because then I can straighten everything up the way I want. McKinley, did you make nice, pretty bins in yours, or did you just shoot them across today?
Shoot them across.
She just shoots them across, and that's just fine. All right, so now let's add some other things. So what I want to add next is I want to add an RGB LED. You can look for an RGB LED in here. It's actually not too far down. Or you can always type, and it'll search for you, right, to make it easier to find. So I'm going to take an RGB LED, and I'm going to rotate it. so that it sticks in the very top 4 rows over on the left-hand side. I intentionally put it over on the left-hand side because by putting it there, some things are going to be easier for me. And then, by the way, I just clicked on the X to clear off my search. The next thing I want to do is I want to add resistors to certain spots of this LEDs. So there's 4 rows on this LED. If you hover over the legs, they're called green, blue, cathode, and red. And probably all those words make sense except for cathode, right? Cathode is another word for something that needs to be at the lower voltage potential, right? So in this case, it needs to go to ground. So connect this line that has the cathode on it to ground. And my wire was black because the last wire I had created was black. So the way this RGB LED works is if you could zoom way in on it, it's actually 3 LEDs in the same package. One that shines red light, one that shines green light, and the other that shines blue light. This is how pixels like on your computer monitor right now work. Your computer monitor probably has literally like millions of different pixels. And we're working with 1 pixel, right? And the neat thing about RGB is you can actually make any color using just RGB light. So those 3 can make any color. There's a lot of light theory things that we could talk about, but it would probably make this video get too long if I explained it all. So you can look up more about RGB light. Just know that's how it works. So the next thing we want to do is, since these really are 3 LEDs, we're going to need 3 resistors. So we talked about resistors last time. So what I'm going to do is I'm going to take a resistor, I'm going to rotate it, and I'm going to pop it onto my board. Now we'll see if your memory is really, really good. The default resistor was 1 kiloohm, but I want to change that to regular ohms, and I want to type in a number here. Sissy, any chance you remember the number?
Yep.
What is
330.
it? 330, that's correct. And the 330 ohm resistor is what makes an LED have the correct amount of brightness. Too small and it'll be brighter, but it might blow up. And too big, it'll be dimmer. So 330 is what I need. Now I actually need 3 of these resistors. Now I could drag over one at a time and change them, but this is actually a shortcut. If you just click on the existing resistor and you hit Control C and then Control V, that's copy paste, and then it'll just kind of make a duplicate for you. Once you spend a lot of time on computers, copy paste, Control C, Control V, you'll use those all the time. So copy paste that top resistor and give me 2 more. So now we've got 1 for the green, 1 for the blue, and 1 down here for the red. Now we need to control these 3 lines from the Arduino Uno. So let's go ahead and draw the wires, and then I'll kind of show you what all we've got. This top one is green, the second one is blue, and the bottom one is red. I actually want to take red, and I'll connect it 9, 10, 11. Ready? I couldn't remember what pin I was going to. And I'll connect it to pin 9. So I'm going to connect it to pin 9 over here. And since it's for the red component, I'm going to switch it red. And then because I couldn't stand not to do it, I'm going to bend the wires so that it is kind of a little easier to see. Cool. So I'm going to kind of make it like that so I can kind of see that it's going to the 9. Next up, I want the green wire. So the green wire is on top here. So I'm going to click on this green wire, and it's going to go to pin 10. So I'm going to make it kind of go around here and then to pin 10. And then I want it to be green. Green is the keyboard shortcut 5. And then the last one is blue. And I want blue to go to pin 11. Now, why did I put them in these spots? And blue is shortcut key 7. Looks like. So I put these in crazy spots, right? But they're in logical spots. If you look at the 9, 10, 11, you'll notice that they all have this like little tilde next to them. And this little tilde means that this pin can be used as a PWM output. So I use the top 3 pins that have tildes, and I put them in order. of red, green, blue, because that's how I think about these LEDs. Now, it is interesting that the actual physical LED is not in order. It goes red, cathode, blue, green. Tinkercad must have thought that was the most common way to actually get one of these, like in your hand. So they tried to do it with like what you could physically buy. It turns out that what you can physically buy actually is in order these days, but Tinkercad still has the traditional one. Great. So if I was following the current, if I wanted to turn on red, here's what happens. I would bring pin 9 high, and with pin 9 high, power would flow through this rail. It would flow through this resistor, and that resistor is important because that limits how much current it is, so that's just the right brightness. Light up the LED. It does a diode drop to cause the light, and then all the LEDs come back down through ground, and then that ground flows back into my board. So it doesn't look like a loop on the circuit, but it is. And it's important that anytime you have current flowing, there's a loop somewhere, right? That makes sense? All right, now in order to see this, we're going to write some code. What we're going to be doing today is all text-based, except for this very first thing. So we're going to do one thing with blocks, and then we're going to move into text and not look back. So with blocks, that should be the default editor, there's some code on here. Don't want any of that code. Take it all, dump it in the trash. Now what I want to do is I want to take this third command. It says set pin, and then it picks some number, 3 in this case, to 0. Now this command is different than the one that says set pin 0 to high. And it's different because this one you can give a number from 0 to 255 for how much you want, right? So if you wanted to turn it all the way on, you would say 255. If you wanted to turn it all the way off, you'd say 0. If you wanted to turn it halfway on, you'd say 127. Do you get the idea? Yeah, I get it. So here's what I want to do. I want to turn on red all the way. In order to turn on red all the way, I need pin 9 because it's connected to the red wire. And then I want to bring 2 more over as well for 10 and 11. And now for this very first test, I want to turn on just red. So I'm going to say, hey, turn on red full blast, but nothing for green and nothing for blue. So when I hit start simulation, what should happen is my LED should turn on fully red. Let's change it. Let's play with some other colors. Let's say we wanted to do fully green. You can test all these or you can just watch mine. Fully green would be 0, 255, 0. I'm sure you can guess what fully blue would be. It's 0, 0, 255. And now here's the interesting thing. You can mix colors as much as you would like. So for example, if I added some red to my blue, I would turn it a light shade of purple. So there's a light purple. If I added all the colors together, so there was 255, 255, 255, it would be white. If I did none of the colors, 0, 0, 0, it would essentially be black, which is off. That's the least exciting one. And then there's some other interesting color combinations. This one I think is always fun. Red and green, they go together and make yellow. Now this is light addition, not light subtraction. So if you had paints and you mix like red paint and green paint together, that uses a system called light subtraction. The light you see is whatever bounces off of there, and it wouldn't be yellow. But with light addition, that's like somebody shining a red flashlight at you and shining a green flashlight at you, and if those two like mix together perfectly, that does create yellow. So light addition is different from light subtraction. Does that kind of sort of make sense, McKinley? A little. All right, you'll get better at it with time. So now what I want to do is I want to transition to text. So right now I can hit blocks plus text, and it'll show me the text for these blocks. Now it's interesting to look at. There's some code that happened in setup. It sets up all these things to be outputs. And then there's some things that happen down inside the loop, and it uses a command called analog write, pin 9, so that kind of makes sense, 255. And the last thing I had in here was 9, 10, 11, 255, 255, 0, and you can see the code that gets generated. So hopefully that makes sense. Now what we're going to do is instead of looking at both, we're going to jump straight into text. So we're going to only do text from this moment forward. So click on text. It warns you, big bold letters, that your blocks are going to go away. Once you go text, you don't come back. So that's fine. So we're going to say continue. So now from this moment forward, we're going to be coding in text, which will be fun. The program still works the same as it did before. It's currently yellow. If I wanted to switch it back to red, I just have to change the text. So 255.00, I run it, and it works with text just as well. And so now we're going to start learning about things using text with the same simple circuit. The first thing we're going to learn about is functions. So what are functions? Functions are little chunks of code that work together to solve some problem. And this chunk of code right here, analog write to 9, 10, and 11, they work together to cause red. So anytime something works together, it could become a function. So let's do this. Type with me and then I'll explain it. So type this. Type void, which is kind of a weird word, red, parenthesis, parenthesis, open curly brace, and then a blank line, and then a closing curly brace. The curly braces, by the way, they're on your keyboard. You have to hold down shift to type them. You'll find them. If you don't hold down shift, you get a square bracket. If you do hold down shift, you get a curly brace. So now what I want to do is I want to cut, cut is Control X, those 3 lines and paste them, Control V, down inside of here. So now what I've done is I've made a little function that I can call anytime I want. So now if I want to make the light be red, I have a function that I can call to do that. So let's go ahead and practice calling it. So let's do this. Type in the word red, parenthesis, parenthesis, semicolon. And what we've done here is we've written a function, red, and we've called the function from our main loop. So this code should work exactly the same as it did before. We've just, instead of like having this code like right inside of the loop, instead we've got a function called red, and then this line of code right here is calling the function red to make it run its code. By the way, there's a couple functions on here. One is the function setup. It's called under the hood to do the setup. And then there's another function loop, and loop is called, and then as soon as loop finishes, the system, like under the hood, it calls the loop function again. And you can do whatever you want in here. So let's go ahead and run it and make sure that it still shows up red. It does, which is good. Let's practice making another function. See if you can pause the video and do this one on your own. Make a function called green, and then instead of calling red, you can comment out red, which is a slash slash. Instead, create a function called green, and then call your function green from the main loop. See if you can make that happen. All right, so I've got mine ready here. So I called the function green, and down here I made the function green. I copy pasted red and just changed a couple things is what I did. And you'll notice that green has a 0 for the red value and a 255 for the green value. Now I'm going to run it to see if it works. So I run it and mine does work. But I also want to show you what happens if you make an error. So coding is very, very picky, right? So for example, let's say on this line where I call green, I had left off the semicolon. If I leave off the semicolon, my code is invalid. It won't compile now. And you're like, well, couldn't they figure out what you meant? And it's like, well, that's not how it works, right? So if I tried to run the simulation now, it's going to show up with a bunch of red text, right? And this red, like you see red everywhere, and your eyes like shut down. You're like, oh, it's terrible. It tells me that there's some error. Now, the error it says is on this line, delay 10 semicolon. Do you think the error is really on that line? Sissy, is it really on that line? No. So this happens all the time in code. It is often the line before where it says the error is, because that's where you actually made the mistake. It's just the compiler it was able to kind of like handle it for a little while and then it exploded later. I was just missing a semicolon up there. Now there's lots of errors that can be made. If you can figure it out, please do figure it out. But know that if it's really a stumper, the Zoom office hours are here to help. So there I've got 2 functions for red and green. I want to make one more function. I'll just do this one with you, called off. So what I do is, well, first I got to stop my simulation. I'm going to show you how I made mine. Is I just copied red. So now I've got a copy of red. So now I've got red, red. It'd be bad to have two. And I'm going to change this one to off, right? And for off, I just want to take all the red, the green, and the blue values and make them 0, 0, and 0. Now what I could do just for fun is I could call my functions. So maybe I'll call red, I'll delay for a second, and then maybe I'll call off, and I'll delay for a second. And then this loop is going to continue to get called. By the way, there's a delay 10 down here, which doesn't really do much. It says minor delay to improve the performance of the simulation. It doesn't do any harm, so I'm going to leave it down there, but it also doesn't really do anything useful. Speaking of which, I'm going to go and clean up some of my comments. So I'm going to go ahead and delete mine off. You can leave comments in there if you want, but they're not really necessary, so I thought I'd just remove them. But what you can do here is you can see how you can mix the functions you write with the functions that are like built in. So I'm calling my function red to turn on the red light, and then I'm calling a built-in function called delay. Delay causes some number of like millisecond delays. Here it's causing 1,000 milliseconds. 1,000 milliseconds is 1 second. So it should be on, and then just wait for a second, and then turn off, and then just wait for a second. So if I run this right now, you can see that it should turn red for a second and then off for a second. Cool. And if you wanted it to flash faster, I mean, you can pick the flashing speed, but you could change that number 1,000 to a smaller number, and that would make it flash faster, right? So if I did 500 there, it would be 500 milliseconds, which would be like half a second on, half a second off. And so it would just kind of flash faster. You can leave the code at whatever state you would like. I'm going to leave mine right here. I'll warn you that some things we're going to do later are going to kind of build on this. So if you wanted to make it crazy, that's fine. But make sure it's not too crazy because we are going to build on this. So this is the first of our topics, functions. Now we're going to learn about some more things in programming. Actually, I want to do more with functions first. Let's do this. This will be fun. Let's make a function that receives arguments. So you see how this delay received an argument? It received this argument of 500, and that told it, hey, function, use this argument to do your job. And you'll notice that there's pin mode up here. It has 2 arguments. You can pass arguments into functions. Let's create a function that receives arguments. Now, normally I would put mine at the very bottom of my page, but I'll tell you what, just to kind of keep all my functions together, I'm going to put it right below the loop. It doesn't matter where you put your function. Arduino is really nice about letting you put them in order. Let's make a function called RGB. Sometimes whenever I name my functions, I use really long names, but I'm trying to keep it short just because I know that typing isn't as easy for everybody, right? Now, RGB, this is my new function. It's going to receive some parameters. It's going to receive an integer number called R. R is going to represent how much red do you want. It's going to receive an integer number called G. And it's going to, probably no surprise, receive an integer number called B. After you type those, you have to type the opening curly brace and then the closing curly brace. Now this opening curly brace and closing curly brace, these are because the language we're using is the C programming language. Technically it's C++, but as far as you're concerned, it's C. So you're learning the programming language C. If you were using a language like Python or Java or JavaScript, they might have different rules for the syntax. But you just kind of have to get used to the syntax for whatever language you learn. I know literally like 20 different languages, and it's not hard to jump from language to language. Computer programming languages, not like German. But they just all have their own little syntaxes, but they all have a lot of the same concepts. So here's this function, and it receives 3 arguments, R, G, and B. Before we even write the insides of this function, let's call it and see kind of how it works. Here's what I want to do. Right now, I'm always making my light be red. I'm going to switch it to use my function RGB. And what I'm going to do is, I don't know, maybe I'll use a fair amount of red. I just kind of picked a number. I did 180. So a fair amount of red and no blue. Oh, I should do something to make it not be the same red. So I chose to do a fair amount of red, so like 2/3 of red or something like that. No green, and then an equal amount of blue as I did red. McKinley, do you know what an equal amount of red and blue with no green would cause? Purple. She's on it. So right now this is going to cause purple. Now, if I were to run my program right now, it would do nothing because it would call this function. It would pass in 180 and 0 and 180, but then my function is blank, right? So we need to write the inside of this function. Because I'm lazy, it's going to be similar to these other functions. So I'm going to do a Control-C and a Control-V to kind of type most of it. Now, the one that I copied from was off, right? But here's what I want to change. In off, it set those three values to 0, 0, and 0. Now I want to set them to R, G, and B. And so this is an important concept for how functions work. So you call the function RGB, you pass in 180, 0, 180, and then the computer goes and runs that function. And the value for R is whatever you passed in first, which is the 180. G is second, which is the 0. And then B is the last one, which happens to also be a 180. So if I run this program now, it should flash with a purple LED. And sure enough, I run it, and it's this cool purple color. Now, just for fun, I want you to make up your own color. So here's what I think would be fun. So open up a new tab. In your new tab, do a search for Color Picker. Now, from Color Picker, what you can do is, so I got a hit. This is Google's Color Picker. What you can do is you can pick any color you want. And notice down here where it's showing you an RGB value. Let's say I wanted just like this perfect shade of purple. This is a pretty good shade right here. Well, this specific shade of purple is 128, 87, 212. So I'm going to take that color and I'm going to pop that color into my code. Pop. And now my code should show exactly that shade of purple. Now this is why we're using the simulator today, because in the real world it's not exactly the same shade of purple. But that color combination of red, green, blue should show up and make essentially that single pixel purple. And it looks like there and there are the exact same. So pause the video, use a color picker, maybe the color picker that Google had here, and pick your very favorite color and see if you can make your LED show up in your very favorite color. All right, McKinley, did you get yours?
Yep.
All right, let's see what you got. What color did you pick? What's McKinley's favoriteest color in the whole world?
Turquoise teal.
So right there, this is McKinley's favorite color in the whole world. Yeah, really, people, instead of saying like the name, like turquoise or teal, they should just say the RGB color combination. You think that's going to catch on?
No.
Probably not. All right, let's do some more stuff. So that was functions and functions with arguments. Now let's learn about variables. Variables are important. Here's what we need to do. So scroll to the very, very top and make yourself a couple lines above the setup even, right? So the very, very top. So what we want to do is we're going to make a variable that's available for the whole program. And the variable is going to be an integer type variable. So int is what you say whenever you have an integer type variable. And it's going to be for a red potentiometer. Now, because I know you don't like typing much, instead of typing like red potentiometer value, I'm going to call this variable rpot, where the P is a capital P. Now, as you might guess, we're probably going to have a potentiometer for green, as well as a potentiometer for blue. So let's go ahead and prepare three variables, rpot, gpot, and bpot. Now, when you declare a variable, what it does, so what is a variable is really where I should start. A variable is a number that your computer knows about, and it can be saved to your computer and then changed and used later. Now, there's three steps in a variable. One is you have to declare that it exists, which is what we've done here. You have to somehow set or change its value, and then you have to use it somewhere. So those are kind of the three parts. Now, if I wanted, I could set the variable's initial value right here at the top to be 0. I don't care if you type that or not, because to be honest, we're going to change it inside of our code. So if you wanted to, you could say it's equal to 0 right now, or you could leave it off, and it just doesn't matter. The important thing is that we're warning the computer, hey, I'm going to have a variable that I'm going to use, and here's its name. So now let's go ahead and use this variable. Here's what we want to do. Inside the loop, at the very top line, we want to set our pot to be something. And what we want to do is we want to read an analog pen that we haven't made yet. We want to read it. So let's go ahead and say analog read. And we're going to wire up a potentiometer to go to analog value 0. So our pot equals analog read 0. So analog read is a function. We've been learning about functions, right? Analog read is a function which receives an argument. This argument says, hey, which pin do I want you to go read? And we're going to read this one right here. It's RA0. Oh, that should be full screen. And RA0 is going to return something. Now, we haven't had a function return anything yet. This is a first for us. But it's going to return a number from 0 to 1023 is the range. So 1023. 1023 is a special number in binary, but we're not going to get into binary today. And that return value is what the functions can do. So our functions that we wrote, they say void. Void is like nothingness, right? So our functions that we wrote return nothing, but this one actually returns an integer. Now, let's go make that potentiometer so that we can actually read that value and I get some number. So let's go make the potentiometer. So hide the code for a second. And let's go ahead and make a potentiometer. You could search for it, but I actually see the potentiometer right here. So I'm going to single click on it over here. I'm going to rotate it. And I'm going to stick it on my board. I'm going to stick mine, looks like row 8. Doesn't really matter where you put it, but I'm going to put it kind of up there so that I've got more space on my board. And I am going to add 3 of these things. So you can just drag 3 over, or if you like to do copy paste, you can highlight it and hit Control C, and then you can hit Control V and pop 3 of them on there, right? So there they are, 1, 2, 3. They're a little crowded towards the top, but it doesn't really matter where you put them. There's going to be one more switch coming later, so you can space them out a little if you want. So here's how a potentiometer works. A potentiometer is like a knob, right? So like if you think of like a soundboard and it's got all these knobs, and these knobs send a signal to the microcontroller that's between like 0 to 5 volts. And so on the top of the potentiometer, you put what the highest extreme is. So I'm going to connect it to my red rail. So I'm going to connect it to my red. I'm going to actually do all 3 of their tops first. So that says, hey, when the dial is turned all the way this way, send a 5-volt signal to my microcontroller. It's really neat to like every time you look at a knob for the rest of your life, you'll think about the fact that you're like just setting what signal goes to a microcontroller, right? And then the bottom goes to ground. So if you turn it the other way, it just goes to ground. And then that middle is the signal that you send to your microcontroller. And so I'm going to take this top one, and I'm going to send it to A0. And it's going to be controlling how much, oops, that went kind of crazy. It's going to be controlling how much red there is. I hit the shortcut key R, and it made my wire go nuts. And then the second one is going to go to A1. And since it's going to be controlling the greenness, I'm going to turn the wire green. Now again, wire colors don't matter. It doesn't matter what color you make your wires. But for the hope of trying to like remember which wire does what, I like to make them colors, just to kind of help me out. And this bottom one, surely you've picked up on the pattern, it's going to be how much blue value there is, which is going to be the B pot variable. Cool, so we've done some wiring. Now we're ready to write some code that actually uses these values. So we've already read the value off here. If you wanted to run your simulation, you totally could. It works. But the problem is that we've declared this variable, our pot. we've set the value rpot, but we haven't used rpot anywhere, right? So that's what we need to do. We need to somehow use that variable. What we're going to do first is we're just going to print it out. That's just kind of a simple way to start. That way we can kind of see the value. In order to do printing, say I have this word down here that says serial monitor. In order to do printing, we have to print things to the serial port. Details I don't want to go into. But in order to use that serial monitor, inside your setup function, you need to do some initialization. And here's what the initialization looks like. You need to type serial.begin, and then you need to give it some speed. I'm choosing to give it a speed of 9600. Now this function is a little different because it's inside of a library. It's inside of the serial library. So whenever you call a function inside of a library, it's a little bit more complex. So you say serial, note that it has to be a capital S, serial.begin. And so that says, hey, call this function begin, look for it inside the serial library, and pass to it the argument 9600. And that says how fast to do communication. That actually stands for 9,600 bits per second. Details. Now what I want to do is I want to use my serial library. So I'm going to say serial dot print. We're going to use serial.print, and we're going to use serial.println today, and we'll also use them tomorrow. Print means display it to the console, and println means display it to the console and then go to a new line. So the first thing I want to do is I want to just put a little label on here. So I'm going to say your R reading is, so I'm kind of preparing it. And then on the next line, I'm going to actually hit them with the value. So I typed that fast, but you can look at it and then you can type it as well. So when this works, when, not if this works, but when this works, here's what's going to happen. It's going to read the analog value. The analog values are from 0 to 1023. Right now it's pointing right at 0, so it's going to be 0 to start with. But as I turn this knob, so like as I dial it up, this value is going to get closer and closer to 1023. Now it's interesting that the voltage is from 0 to 5, but analog readings display from 0 to 1023. So if it's like 2.5 volts, that's right in the middle, which would be like a 512. We'll see it once we get into it. And you'll also notice that here I say print, which means like keep me on the same line. And then here I say println, which means like go down to the next line when you print next time. So when you're ready, click on Start Simulation, and then click on Serial Monitor here. And you can see that it says R equals, and then mine's just printing out a whole bunch of zeros. Now what I want to do is I want to turn this knob. So I turn it to roughly the middle here. Roughly the middle looks like it's 511. And then if I was to take this knob, and I can kind of like click it and drag it, and I was to turn the knob all the way up, it would show me 1023. And you can see that there's a lot of different values in between. And the pace at which it prints depends on how long your loop is here. So that's why I kept my loop pretty short. So here's the challenge for you. We currently are reading analog 0, so A0 right here. We're saving that value off to rpot, and then we're printing it. But see if you can copy these lines of code, so this chunk, so make 2 more copies of it, and modify it so that it prints the red, the green, and the blue all on a single line, and then goes to the next line after. So I'm going to pause the video. I'm going to see if you can do that task all on your own. All right, so I'm working on mine. I'm not done yet. So I did what you probably did, is I copied this and I kind of pasted it 2 more times. I switched rpot to be gpot in 2 places, and then bpot in 2 places, and then G to be here and the B to be here. Now what some people miss is they forget to change this, what pin am I reading? So we want to read pin 0 for red, and then pin 1, and then pin 2. Now I could run it and it'll work now, but it has one problem, one bug in it. And that's that it kind of is hard to read because it prints RGB and RGB. It would be better if they were all printed like on one line, right? So RG and B were one line, and then next time it's all one line. McKinley, do you have any ideas for how we can make it print all on one line? Any ideas? Not yet. So LN stands for like line, so print line. And this LN on this one is causing it to go to a new line. So just take off the LN. This one, LN on this one is making it go to a new line, so take it off that one as well. We only want it in one place. We want it after blue. So after blue prints, then go to a new line. So now I can try it again. So now, oh, and by the way, you can always click on clear if you want to clear your serial monitor. So now it's displaying the value of my red, green, and blue potentiometer. You can play with the formatting to your heart's content. Like it might look better for me, I don't know, maybe me and my eyes if I didn't have a space after the equals, but I had extra space before the label. Doesn't matter, right? You decide how it looks good for you, and then once you've got a system that you think looks good, then you can play with it. Now try turning these potentiometers. So if I take red all the way up, I can see that it goes to 1023. If I crank green all the way up, I can see that it gets up to 1023. And then if I take blue all the way up, I can see that it goes to 1023. This is a very good test because if you are not seeing this, then something's wrong and you need to fix that before going on to the next step, right? So there are blues in the middle, and then here blues is the bottom. But you should be able to turn these knobs, and here I do find it's actually easier to kind of drag them around. Usually I don't drag and take the head. But if you turn these knobs, you should be able to see the values of these knobs. If you've got that working, then you're ready for the next step. If you don't have that working, I do recommend that you kind of pause until it's working, right? So now what do we want to do as the next step? What I really want to do is I want to use these knobs to control my LED, right? So that I can like live update what color it is. So that's almost going to work, almost. So here's what almost works. Let's go ahead and do this together. Take your line of code where you put in your favorite color and comment it out. And instead type RGB. And the three parameters you're going to pass in are going to be RPOT, GPOT, and BPOT. So this is almost going to work, but not quite. So what this would do is it would take that potentiometer value and pass it into your function as well as your green and your blue. Now here's the one trouble is RPOT, a potentiometer, goes from 0 to 1023, right, or 1023. Whereas this function down here, analog right, it only gets values from 0 to 255. So they're a different range. So it's kind of like if I said, hey, McKinley, guess a number from 1 to 10, and she says 87. I'd be like, that's not a valid range. So what we've got to do is this. It is actually only a divide by 4 away from being in the correct range. So here's what I'm going to do. I'm going to take RPOT, and before I pass it into the function, I'm going to take RPOT and divide it by 4. And then that is what I'm going to pass in the function. So if the potentiometer says 1,000, then I'm going to tell the function 250, right? So it's a scaling system. So now when I run it, so I hit start simulation, what it should do is it should use my potentiometer to decide what color it is. So right now I've got just a little bit of blue, and so that kind of looks purpley to me, but it's supposedly blue. If I crank blue all the way up, you can see I get a nice crisp blue. If I take red and crank it all the way up, I get a purple. And then if I take green all the way up as well, I get a white, right? If I take the blue out of the equation, red and green make yellow. And it's a neat way to kind of like play with different color combinations. Now, to be honest, it's probably easier to play with tools like the color chooser that you had on Google. But with this, like, and you can imagine building it, you can turn these knobs and you can tweak to get whatever color you want. So see if you can get that together. And I'm going to help my camper out, and then we'll move on to the next step. All right, so we're doing good. So we've learned the big picture concept of functions. We've learned the big picture concept of variables. So you save some value off, and then here we're printing it, and then we're also using it to control a color, and we're having a little fun as well. Let's go to our next big concept in coding, and that's if statements. And the idea is we're kind of showing you some of the big picture concepts. We're not going in depth into anybody. So right now, our LED is flashing. And it's flashing because it's being turned on here. And then really it's these 3 lines of code that make it flash, right? So like, let's imagine we had an if statement where maybe we do those 3 lines of code, or maybe we don't. That would determine if it's always on or if it's flashing, right? So our goal is, we'll go ahead and prep our code a little bit, is we're going to say if some condition is true. Now the condition in the middle here, we're going to read some analog pin, but if some condition is true, then we're going to do some stuff. Before I fill in the condition, I'm going to go ahead and write the rest of this code. So if some condition, which I haven't filled in yet, is true, then run this code. And what we're going to do is we're going to take these 3 lines where it says delay 500 and then off and then delay 500. Those 3 lines are what make it flash. So if some condition is true, then do those lines. And then if it's not true, then just don't do them at all. And if you don't do them at all, it'll just be steady on. So here's what we want to do. We want to do a digital read of pin 2. So what we're going to do is, our condition is we're going to read pin 2. And if pin 2 is a high voltage, like if it's 5 volts, if it's a high voltage, then it's going to do this stuff. And if it's a low voltage, then it won't. So let's go ahead and wire that up. And so if statements are very common in coding. You type them all the time. And we're just kind of giving you an example of it. So I'm going to go do some wiring. So I'm going to temporarily hide my code. So pause the video if you need so that you can have that code in place. And I'm going to go do a little wiring. So what I want to add this time is a slide switch. So go ahead and click on slide switch and rotate it around. And you can drop it into your board. And a slide switch, it's similar to a push button in that it can go high and low. We used push buttons yesterday. The nice thing about this one is it stays in that position. So you click it and it stays in that position instead of having to hold it down when you want it to happen. And a slide switch actually works just like a potentiometer, which is kind of funny. The top, we're going to connect to 5 volts. The bottom, we're going to connect to ground. And then the middle, we're going to connect to pin 2. And you can make the wire some crazy color if you want. I picked yellow just to be silly. Also, just to be a rebel, I'm just going to let it shoot straight across. And so a slide switch is actually very similar to potentiometer. The difference is there's no in-between values, right? There's all the way on or there's all the way off. And those words, by the way, all the way on, all the way off, that means something is digital. That means it's all the way on, all the way off. Versus the potentiometers are analog. They can have a range of values. So that's what those words digital and analog really mean. So now let's go ahead and look at our code and let's predict what's going to happen. So when this switch is at the top, I expect it to be flashing. Because if this is getting a 5 volts, if the switch is at the top, I expect it to be flashing. And then when it's not at the top, I expect it to be no flashing, just solid on. So let's go ahead and start the simulation. And sure enough, right now, my LED is solid on. But as soon as I flip the switch, it should switch to flashing again. So what we've made here, and I know it seems kind of simple, we've made an if statement, right? And if statements are important in code. And if statements always follow the same pattern where they have some condition. And then if that condition is true, then you run the code that's inside of there. Another thing you could do with if statements, and I'm just going to kind of mention this, you could add an else statement, and this is code that runs if it's false. I don't really have any code that I want to run if it's false, but maybe I'll stick in just a delay, just for fun, right? So you don't have to type this. I don't really care if you do or not, but I just wanted to point out that if it's true, you run this code, and then you can also optionally have an else to say if it's false, then run that code, right? And we'll do some more complex things with if statements tomorrow. But I wanted to show them here. So we've actually hit almost all of the major coding concepts that I wanted to show you. We've got functions, we've got variables, and we've got if statements, right? So those are the big few. If I was gonna add one more, and what the heck, we got the energy for one more, Sissy? All right, if I was gonna add one more, it'd be a for loop. Let's show you a for loop. Now I don't, just because my board's already kind of complex enough, I don't want to do anything with my board. I'm just going to use the serial monitor to show you a for loop. So here's what I want you to do. Find the setup function. Make sure your code is not running. And make a couple lines at the bottom of your setup function. And here's what we're going to do. We're going to type a for loop. So I'm going to type it first, and then I'm going to talk about it. Just because sometimes it's easier to type the whole thing, and then afterwards we'll talk about it. So typing away very quickly. Pause the video as you need, or you can try to type as you watch me type. But what I'm going to do is I'm going to make a for loop. And then inside that for loop, I'm going to print something out and then do a small delay. So pause the video as you need until you type this, and then let's run it and see what it does. So I'll tell you what, I'll run it first to see what it does. And what this code does is it counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is kind of interesting. And then it does some other stuff. Let's look at how it does it. So this is a for loop. There's a couple of different types of loops in coding. There's a forever loop that runs like forever, or there's a for loop that runs a set number of times. And here I'm just showing you an example of a for loop. And the way this works is it says there's 3 clauses in here. There's the setup clause, there's the condition clause, and then there's the increment clause. And they're divided by semicolons. And this is just the syntax that C uses. Every language is going to have different syntax. And what it says here is it says, hey, start me off with a variable called k, where k is equal to 0. And then it says, keep running this loop so long as k is less than 10. Notice less than. If you wanted it to include 10, you'd have to say less than, oops, I got to stop the simulation before I can type, less than equal to, and this is read less than or equal to 10. And then here's the increment. It says after each loop, so like between every run of this loop, take k and make k equal to what it was before plus 1 more. So what I want you to do is I want you to play with the initial statement, the condition, and the increment, and see if you can print different things. And then inside the loop, what it's doing is it's just printing the number using serial print ln like we know before. And then I was choosing to make a short delay. If you were to do a bigger number, like 100 or something, make sure to make your delay a little less, because otherwise your program is going to seem to hang until that finishes. So here, if I were to go from 0 up to and including 100, that you can see I did that pretty quickly. You could also change things to where you say, hey, instead of counting by 1, count by tens, right? And so now it just goes 0, 10, 20, 30, 40, 50, 60, all the way up to 100. So see if you can play with your loop a little bit, just to kind of see how loops work. And that's really the end of this day. So we learned about functions, we learned about variables, we learned about if statements, and then our last one here is we learned about loops. Now, if you decide to spend your life coding, you will use these concepts over and over and over and over and over again. We just kind of introduced them today. In our next video tomorrow, there's a remote control car that we'll do together. Also, if you want to do more coding, there's an extra video for today that uses an LCD and a servo. It's pretty cool. If you want to do that, you can. It's optional. But we just want you to get better at coding. Now, one thing that you will definitely notice about coding is that it is much pickier when you're using text versus when you're using blocks. So McKinley, I know, is sitting right here next to me. McKinley, did more things go wrong when you're coding with text as compared to coding with blocks?
Yes.
Yes. Do you find that it's very picky on getting things exactly perfect?
Yes.
Yes. Is that common and expected? Is it okay and still fun? Not as fun sometimes. Very honest answer. I appreciate that. All right, so we appreciate you you coming to code with us. We appreciate you learning text-based programming. There's going to be more tomorrow, but this is how real software developers spend their lives, and I wanted to spend some time exposing you to text-based programming. All right, see you next time. Bye.